Welcome to day two, uh, where I will be demoing on how to install Eagle software for circuit design and simulations and getting started to using Eagle software. So all you're expected to do is to go to use your internet browser and search for download and type something like download Eagle software for free. Download Eagle software for free. So you're expected to download the latest version of Eagle, which is version 9.6.0. It's at this time. So click on this. So I told you in the last class that if you want to download Eagle, so you expected to go to Autodesk uh, website, which is this. Then the next thing is to, so these are different packages for each operating system you are making use of. There is an Eagle package for Mac, for Linux, for Windows of it. So I'm using Windows. So if I will download it, I'll click on download. So we can start downloading. So I have this software on my system again, so I don't need to to download it again. So after successful downloading, so the next thing is to come here, and as you can see, this is the software. The next thing is to click on these so that we can install it. Yes. So the next thing, you follow the instruction, you accept the agreement, you read the license agreement there, and you click on next. So where the installation will be saved, the folder will be this, so you can leave it to the default. So you can create a desktop shortcut for it, and then you click on install. So because I already have Eagle with me, I already have Eagle on my laptop, so I don't need to install it again. So you can, if you haven't downloaded yours, then you can do the downloading by our installation by clicking on install here. So after successful installations, uh, then you can now uh, after successful installation, so the next thing here is so you open, you search for it here, or you click on the shortcut that has been created on the desktop, and then it's going to open the control panel, as you can see here. So the next thing here is to understand how the Eagle software works. So the next thing, if you are just downloading, installing yours, you are expected to sign in here. And if you click on sign in here, if you have an account on Autodesk, you can sign in. And if you don't, you click on sign up. Then you create an account on Autodesk, and after successful creation, so you'll be signed in here and the name will appear in. So in the home page, that's where you get the latest news about the software, about other softwares from Autodesk like Fusion 360, and which are used for designing CAD, CAM, and other pieces for visualizing PCB software like that. So this is the control panel for the software. So you want to create a new file, new project, you click on file, then new, depends on what you want to create. It's massive diagram, a PCB, want to create a new library, design block, all those stuff like that. So the view is just Other stuffs which will be like to display other stuffs here, refresh and other stuff like that. You refresh the page, to refresh the control panel. So the options are where you can get the directories for each of the libraries and other directories in the software, the login. So the windows which will display the control panel, and here you can, if you open a project, and that will be displayed as your health. That's where you can get information about Eagle and how to get started with it. So the libraries are very important part of Eagle. That's where each of the components I'll be using here are being saved. So each component has its own library, resistor, capacitors, and other components like that. So they have the libraries. So for the user defined libraries, I have not created one. So I have the some libraries that are created. So I don't mean have a library that are created, so I will see the folder here. This will be the folder name and the role and the library I created, but I have none of the libraries there. So these are the Eagle libraries for each component you're having, like logic, like Phoenix connectors. Each component has their own components here, the thyristors and the transformers and other switches and other components like that. So these are the libraries that are depicting each of the components. So like a transistor, a PMP transistor like this, which has different types of bits, NPN, and these are its bits like this is what. So this is the pictorial package or the 3D package of the library of the transistor of the component in the library of the component in the MPN transistors library. So that's just about the library. Okay. So the design blocks are very important part of uh, of Eagle. So the design blocks are just like the simple blocks that the simple diagrams that like pre-designed diagrams like that, like a 3.3 volts uh, controller, meaning converting from this to this, regulating from or like converting from a 3 volts voltage to 40 volt DC voltage. And these are uh, already designed or created diagrams, be it simple or complex diagrams like that. So these are the design blocks which are well pre-designed diagrams and design rules as well. As well, you're going to get a DRU for each of the stuffs they are having, each of the components they are having. You want to understand how they are being designed, the distance between each components, and all those stuffs like that. The ULP, which is very important part of, is a file under Eagle software, and this file is very important as well. So we have different types. The ULP will tell you each part of the schematic diagram. So the scripts gives information, the count jobs, the spice models, which should be the one we'll be using for the for the simulations, the NG spice model we'll be using for the for the simulations and pre-designed projects as well, like this NG spice example. This for example, these are example simulations. As you can see, the probe, the voltage probe are attached here, and each of these probes will be simulated. So Yeah, so let's get started. Let's see what we can do. Yeah, so we want to start the project, just go to file and click on new projects. Click on, we want to create a schematic diagram. So this is how the Eagle software's layout looks like. And this contains different tools like file edits, draw, options, help, and those stuff. And under filers, where you can have different format, the new, the open. You have an already created projects, so you can open it here. You can save. You can save as Eagle. You can save on different Eagle versions, and you can switch to PCB. So one advantage of Eagle is that you can switch from schematic to PCB. So if you design anything on this page like that and you switch to board, the same design, the same component you have on schematic will be created for the PCB. Then you can just lay everything out on the PCB. So if you want to import a project, you can do that. If you want to export each of the projects as an image or any other file format, you can do that here as well. So for the script and ULP, you can execute and run them as well. So looking at the edits, these are very important parts. These are the tools we'll be making use of, and they are here as well. So add all those stuff. Add is just to like add a part, add a component to the workspace. Escape. So as time goes on, you understand how to make use of all these tools here and the tools here as well. So the important part of another important part of this is the simulations. From here to here for simulations, this simulates this where we can get the waveform result. This where we can have the voltage probe. At the end of the day, you understand how to make use of all this. Now, so let's get started. Let's design a very simple circuit. So the circuits we are going to design here it will be like to turn on an LED, a light emitting diode, using and like it limits the current that will be coming from the voltage source, which is the battery, with a 1K resistor, meaning the LED, the resistor, and the battery. So these are simple projects we'll be doing for today. Yeah. So if you want to get started, the important place to go is the add. This is where you can add each part, each component. So you click on add. So before adding any components, the important thing, the necessary thing you need to do is to add a frame, which will serve as a workspace for us. You add a frame to it. So to add a frame, just come to search here and type frame. So there are different types of frame here, the A3 frame, and different types of frame here. But during the course of this, we're going to be making use of frame A size, which has its own dimension. This is a dimension. It depends on the project's dimensions you want. And maybe any projects you want to do, if you are given the dimension to use, this is a form of an A4 paper. So it depends. It depends. This is the dimension for these, for the letter portrait, for this dimension as well, 401 by 266 millimeters. So we are making use of an A size frame here. So the next thing is to attach this frame here by clicking on it like this. So after left clicking on it, then the frame will never be deleted. So to escape or to delete, to remove this frame from the cursor, you need to tap on escape, ESC on the keyboard, escape. So typing on that, then you cancel it there. So you can see the frame has gone. So the next thing is to save. It's to save the workspace. You know, the title here is untitled. So let's see if we save it, whether it's going to be titled. So let's save it. My first Let's save it with my first project. Let's save it with my first project. So these are the saved with my first project. So as we continued, the title will be changed and the date will be formatted as well. So, to create a part, you come to add parts. So want to add an LED, type of LED. So there are different displays that you can use here. But we are making use of a simple LED. So you come to LED here. In here, you come here, you take any of this LED, although they have different formats, the top and bottom types of LED. So we are going to make use of this top based. So after clicking on it, you double click on it. When you double click on it, you'll be able to add it. So we are only making use of one, then we escape it. So the next thing is the resistor. Resistor. So for the resistor, we have different type of resistor as well. So these are the types of resistors we're having. The American symbol, American US-based resistor, there is US-based resistor, and there is EU, European Union resistor. And this is the symbol, meaning this symbol is for European Union, and this symbol is for US. So you're making use of this resistor, then you add the resistor again. Escape again. So the last components we are adding is a battery. So there are different batteries there. So this is a lithium battery. So you can make, this is how the battery looks like, a 3 volts battery. So let's make use of this 3 volt battery. So yeah. So these are the components we have added and everything. These are the simple circuits you want to do. This is simple circuit using all the simple components like that. So the next thing is to connect each of these components together. So a battery has both negative and positive side, which has two terminals, positive and negative, positive and negative terminals. A resistor has no terminal; it's only is a non-polarized passive component, while an LED, which is light emitting diode, is a type of diode which are being used as an indicator to check whether there is a flow of current in a circuit, and it has both negative and positive terminal as well. So the next thing is to control or to like connect each of these. So how do we connect each of these components? So we come to this, there is net. Before connecting them, so the next thing is to like rearrange or rearranging the orientation of each component like that. So we want to connect it this way, and the battery is the orientation of the battery is not that okay for us to connect it in this way. So now let's say we connect the positive side of the diode to the resistor like this. So now we want to connect the other side of the resistor to the positive part of the battery. But we can't do that now because the battery is not well oriented. So the next thing is to orient the battery, like to rotate the battery. So to rotate the battery from here, we can rotate. So you click on this. Can you see the orientation has been changed? The positive side, which we needed, is here, and the negative side is here. So the next thing is to connect them. Connect this one with this, and connect, and connect. And connect. So this has been connected. The positive side, the positive terminal of the battery has been connected to one side of the resistor, and the other side of the resistor has been connected to the positive side of the LED, and the negative part of the LED has been connected to the negative part of the battery. So the next thing is to add the ground to it. So to add this, you come to add part as well, and click on GND, ground. So there are different types of ground. This ground is for simulations, which is the ngSpice. So we don't need that. So we need the one for supply. You can use this or you can use this. So let's make use of this. So escape and close it again. So the next thing, let's connect the ground to this. Yes, we merge it together. So the ground has been connected. The negative, the negative side has been connected together and they are indicated with ground. And the positive side has been connected to the resistor to the LED as well. So the next thing is to rename or add values to some of the components. If you want to rename the LED, you can click on rename here. This is for rename, and this is for adding value. R2 here, you can see R2 is bolded here, and 10K is highlighted here as well, which is for value. So to rename any of our component, we tap on it LED. So we can only rename this LED. We can rename this LRP4. So for the resistor, we can rename it R1, but we don't want to rename it. R is being used for this is what is called the labeling. During our last class, we discussed about some of the components of a circuit diagram, and labeling is part of it. This R1 has been labeled for a resistor. So the same thing here, which is for battery G1, you can change this from G1 to B1. Okay, so this has been changed or labeled as B1 for battery. So after renaming, we can then add values to the needed. Let's check whether we can add value to LED. LED has no user definable value. So do you want to change this? So here we can only change this. We can change this by removing it. So R1 had the value, let's say 1 kilo ohms resistor. So it's we had it. So meaning this resistor will be formatted as a 1 kilo ohms resistor. So for the battery as well, we need to change the battery because we are using a lithium battery, which is a CR series. So we can leave it this way. But in the case that you want to just want to make use of this battery, we can just say this battery has already been formatted as a 3-volt battery. So you can just leave this. So, and this is how an electronic circuits are being designed. It is a simple circuit diagram, and each of these this diagram combine all the components of a circuit diagram, the symbol, the connection, the hierarchy, and the labeling annotations as well. So now it is always a good way to go if you can see the sheet here, you will discover that our circuit diagram is not at the middle of the frame, and it's always better or necessary for us to make sure the diagram is at the middle of the frame so that the design will be wow, or the design will be amazing. So now to move these circuits to move this circuit diagram to the center, so we need to come here. So you need to click on move here. This is for grouping. For move, you can only move one at a time. For move, we can only move one at a time. For group, if we can use this to group all the circuits here, then tap on any of those components. So that's that about that. We save it again. So At a later time, we open this, the dates will be formatted here. And this is a simple electronic circuit diagram. And so this will end our class today. Thank you for joining us today, and be prepared for the next class where we'll be designing a more complex circuits and how to simulate those circuits. Thank you.